welcome to our channel. This is Science Lectures. Please consider subscribing and comment in the comment section and like our videos. So we are still continuing with our series of cell biology and we are under transport. Today we want to have a look at active transport. So first of all, we need to know what active transport is and the types of active transport. So let's start off with our active transport. So what is active transport? Active transport is the movement of molecules. We have movement of molecules from a low concentration to a high concentration. We are having molecules moving from a region of low concentration to a high concentration using energy. This energy can be in form of ATP. Using energy, of course, this happens against the concentration gradient. So it's against the concentration gradient. In other words, we are transporting this molecule uphill. So it is moving the molecule uphill. But we need energy in form of ATP to effect this process. So in active transport, in other words, to make it clear, we have a molecule from low concentration. Let's say a molecule is concentrated, has a low concentration. Let's say the concentration of this molecule is 30%, I'm assuming, then being transported to where it is in a high concentration. Let's say to where it is, it's 70%, high concentration, where it is 70% in concentration. But for us to effect the process, we need energy in form of ATP, and we also need, we are also transporting uphill. The molecule is being transported uphill because we incur energy in form of ATP. So this is it basically for the introduction of active transport. And some molecules in the body can be transported by active transport. For example, we look at what we call the sodium potassium ATPase pump. It will use the same concept of active transport. So that is it for active transport, the introduction. We are transporting a molecule from a low concentration to a high concentration gradient using energy, but against the concentration gradient, so the molecule is moving uphill. Unlike diffusion, where we have a molecule moving from high concentration to low concentration, here, and without ATP in diffusion, in simple diffusion, but here we need energy in form of ATP, molecule from low concentration to a region of its high concentration. So it happens uphill transport. So, but what else do we need to know with this active transport? The other types, very important to know the types. So active transport is divided into two. The types of active transport. We have two basic types. That is primary active transport, and secondary active transport. And those are the types of active transport, primary and secondary. We'll have a look at these types of active transport. The primary, then secondary active transport. But before we go deeper into these types, we need also to have an overview of what active transport will need. So active transport needs transport proteins. So we need some transport proteins. And if we are in primary active transport, we need transport proteins that are pumps, the protein pumps. And these pumps should have an enzyme that breaks down ATP. And that enzyme is called, it should have an ATPase. We should have ATPase enzymes present. And we should have an ATP binding site on the pump. So let's say this is our pump. And of course, that is the pump used for transportation. So if this is the membrane, this is our membrane, we'll have an ATP binding inside somewhere where ATP binds, but the ATP that binds is hydrolyzed to ADP and pi and a phosphate. This phosphate provides energy that aids in transportation of the molecule. Let's say this is a cell and we want to transport sodium ions out. So this pump will have 3 sodium ions moving outside the cell and 2 potassium ions out the cell after hydrolysis of the ATP to ADP and pi. So this is key in active transport, more so in primary active transport where we use energy in form of ATP directly. So we need an ATP binding site on the carrier. When ATP binds, it is hydrolyzed by the ATPase enzymes, ATPases. When ATPases hydrolyze, they form the phosphate, which provides energy for transportation of the molecule. In this case, this pump will move out 3 sodium ions and take in 2 potassium ions, as we are saying. So in other words, we need ATP, and the molecule transported should be transported from a region of its low concentration to a region where it is in a high concentration. So that is very important for us to know. Then, before we go further with more details on active transport, there is something here we also need to know, and it is called the electrochemical gradient. So we have what we call the concept of the electrochemical gradient. And this electrochemical gradient is a combination of the concentration gradient, and the electrical gradient. So let's assume we have a cell. So this is my animal cell. Inside of the cell, we know inside the cell is always negatively charged due to presence of proteins inside the cell. It's always negatively charged, and there are proteins inside the cell. And it happens to be that inside the cell we have low sodium ions as compared to outside the cell. And inside the cell we have high potassium ions as compared to the outside of the cell. In other words, inside our cell, we have low sodium ions, but we have a negative charge. Inside is negatively charged. But we also have high potassium ions inside the cell. So the negative charge is what we refer to as the electric gradient, and the concentration of the ions give us what we call the concentration gradient. So in this cell, if we have high concentration of sodium ions, low concentration of sodium ions inside the cell, that means that the concentration gradient pulls the high sodium ions inside the cell. So our concentration gradient for the sodium ions moves them inside the cell. What will happen with the electrical gradient? So the electrical gradient of these sodium ions will also pull them inside the cell. because inside the cell is negatively charged and the sodium ions are positively charged, so they will be pulled towards the inside because there is a charge which is opposite to the ones of the sodium ions. So concentration gradient will lead them inside the cell because they have a low concentration inside the cell, and the electrical gradient will also lead the sodium ions into the cell. So let's have a look at the potassium ions. What will happen? So for the potassium ions, the concentration gradient, remember we said there are many inside the cell. So the concentration gradient will pull them outside, will move them towards the outside of the cell because they have a high concentration inside the cell, but the electrical gradient will move them to the inside of the cell because they are also positively charged and the inside of the cell is negatively charged. So they will be attracted to the inside. So this concept is very important for us to understand primary active transport and secondary active transport.